Good morning, everyone. Here's to the one we got. Let's go ahead and start solving equations today. Actually, this is, again, all review from Algebra 1, so it should go pretty smoothly. We'll start off by giving you a very simple equation. Remember, equations are expressions with an equal sign in it that you have to solve for. Okay, in this case, we're solving for x. You guys know how to isolate the variable x by doing inverse operations to get to the answer. So the first thing we're going to do is we're going to get these two guys together. And it's your choice. You can either bring the x's to the left-hand side or bring the x's to the right-hand side. It doesn't matter to me as long as they're all on the same side. I'm just going to go ahead and bring this 4x over by subtracting 4x to the other side. And that gives us 80 equals negative 10x. And then to isolate the x, we get rid of this negative 10 by dividing both sides by negative 10. And we have x equals negative 8. All right, very nice. Again, I think your Algebra 1 teacher preferred that you put the variable on the left-hand side and the number on the right-hand side. For me, it does not matter, so we are all good to go. All right, let's go ahead and solve some equations with fractions, because sometimes equations with fractions can get a little bit complicated. All right, but I am going to show you two different ways to do it. Here's the first way. Is when you add and subtract fractions, they have to have the same common denominator. In this case, we don't have a common denominator. We have a 3, a 3, a 6, and then this one doesn't have a denominator, so we can put a 1 underneath it, and so it now has a denominator, but it's still not the same. All right, so in order to work with these fractions, you have to have a common denominator. And to get a common denominator, you have to find the least common multiple. What number can all of these be made so that they're all the same? And I've done it down here. I've turned them all into 6's. Okay, and the way we do that is we just take the 3, and if we wanted to change it to a 6, we have to multiply it by 2. In order to do that, we have to multiply the top by 2 as well. And so there's how I got that 2. Same thing here. To make this a 6, you multiply everything with a 2, and so the 2 times 4 gives us that 8. Continue the process. This is already a 6, so you don't really have to multiply anything to the top, and that's why we have this 1. And in order to get this 1 into a 6, we multiply by 6, so you have to multiply the top by 6, and that's how we have that. All right, let's clean that up a little bit. And now that we have the same denominator, we can work with it. We can go ahead and move things around by bringing the x's all on one side and then bringing the numbers without the x's to the other side. And there we have it. 3 over 6x is equal to 2 over 6. To solve this, you're going to go ahead and just cross multiply. 18x is equal to 12. Divide both sides by 18. And our answer is 12 over 18, but you always have to remember to reduce your answers. And that gives us 2 over 3. Okay? Let's go ahead and do it a different way. And that way you might have been taught in Algebra 1 as a shortcut to get rid of fractions altogether. Because some people don't like working with fractions, so we just want to get rid of it altogether. Okay, so that method to get rid of all of the fractions, let me clean this up just a little bit. To get rid of all the fractions, we're going to go ahead and take our entire equation and multiply it by that least common multiple, 6. Because all of these numbers can go into 6. All right. So let's go ahead and multiply everything in there by 6. Distributing that in, you have 6 over 3. You have minus 24 over 3. And then negative 1 times 6 is negative 6. And don't forget to multiply that 1 as well. And that's what we have. 6 over 3x minus 24 over 3 is negative 6 over 6x minus 6. And I know I said it was going to get rid of fractions, and they're still fractions, but don't worry. All you got to do is reduce them. 6 over 3 is 2. 24 over 3 is 8. And then 6 over 6 is 1. And then this one doesn't have a fraction, so we just leave it alone. Alright, and there it is. As promised, all the fractions are gone. And now it's a pretty basic Algebra 1 problem. Bring the x to the other side. Bring the negative 8 to this side. We have 3x equals 2, and then of course divide both sides by 3, and we have x equals 2/3. And you notice that we have the same answers using 2 different methods. Okay, so whatever method you're comfortable with, go ahead and use that way. Okay, so our next slide is labeled weird equations. Why are they weird? It looks like a normal equation where you have to solve, but go ahead and try to solve the 2 equations and see what happens. We'll start off with this one over here. Combine like terms first, the 6x minus 3x. Bring 3x over. When you do that, you notice something weird happens. What happened? The x kind of just goes away. And you're left with just 11 equals 5. Alright, and usually that doesn't happen, but sometimes the x just disappears, and then you have just 11 equals x. And obviously we know that 11 is never equal to x, so we say that this has no solutions, and the symbol for no solutions is just a 0 with the cross over it. Alright, let's go ahead and take a look at this next one. Why is it weird when you try to solve for it? We're going to go ahead and do it. 4 and 1 is 5. The 6 and the negative 2x is 4x. When you try to solve it out, the x also goes away. But this one is a little bit different. This one, when the x goes away, you just have 5 equals a 5. And it turns out that when you have a number equal itself, that it's not no solution, but instead it is all real numbers. So it turns out that you can plug any number into this x. Make sure it's the same number. And it'll always be true. Okay? And the symbol for all real numbers is just a fancy R. If you guys want to learn how to draw it, it's just 2 bars and then that symbol. Alright, and that stands for all real numbers. Next up, we have literal equations. So literal equations are just equations that you've seen before. They're formulas that have a whole bunch of variables in it. If you look at this equation we have here, you should recognize it from geometry. 1/2 BH is equal to A. The B stands for the base, the H stands for the height, the A stands for the area. So area equals 1/2 base times height. That is the formula for the area of a triangle. Alright, but we won't worry about the shapes right now. We're going to be worrying about the algebra. They want you to solve for the letter B. So basically they want you to isolate this B, which means you have to bring that 1/2 to the other side, and you have to bring the H to the other side. Okay, and that's pretty easy to do. you're going to go to get rid of the 1/2. You have to multiply both sides by 1/2, or by its reciprocal. So multiply both sides by 2/1. And I'll show you what that looks like. If I multiply both sides by 2/1, these cancel out, and this is just 2a. And that's how I got to this part. And then there's one more step left, just to get rid of the h. To bring it to the other side, you have to divide it on both sides. So divide both sides by h, divide both sides by h. Those h's go away, and we have b equals 2a/h. Now I know you guys are used to having equations where it's just a letter equals a number, but these are literal equations, so you're going to have a whole bunch of letters and numbers still in it, as long as the letter they're asking you to solve for is by itself. Alright, let's go ahead and do another one of these. This one looks kind of complicated because it has that fraction in there. We are asked to solve for f. So we have to isolate f. We have to get rid of the 5, the 9, and the -32. Alright, let's go ahead. You have to work backwards to get rid of the 5 and the 9. Alright, just like before, to get rid of the fraction, you just multiply both sides by the reciprocal. So 9/5. And this 9/5 cancels that with the 5/9. And so we have 9/5c is equal to f minus 32. And then to get rid of the 32, you just have to add it to the other side to get 9/5c plus 32 equals f. Now, does anyone recognize the formula that we have? The last one was the area of a triangle, but what is c equals 5/9 times the quantity of f minus 32? The c and the f should be a hint. They stand for Celsius and Fahrenheit. Alright, so that's the equation to convert from Celsius to Fahrenheit when you're talking about temperature. Last thing we have for the day is a word problem. I know word problems are always fun because you get to work with all these numbers, but then you get to read about it first and then try to convert it to math and then solve the math. So they are pretty exciting, and you've done a whole bunch of these before, and so just a little review. You have those two buses again that go left and right, leaving LA at the same time in opposite directions. One bus travels 40 miles an hour and the other one is 20 miles an hour, and they're going opposite directions. How many hours is it going to take for them to be 4,000 miles apart? So typical word problem when it comes to writing equations. The one thing you do need to remember is that the formula for distance and rate and time is d equals rt. Okay, distance equals rate times time. You're going to have to come up with two different equations, one for the first bus and one for the second bus. Here's the equation for the first bus. Its distance, d1, is equal to 40 miles an hour times the time. Here's the one for the second bus. Its distance is 20 miles an hour times its time. And then the other part of the problem is this 4,000. The total distance of them together is going to be 4,000 miles apart. So their distances together, when you're talking about distances together, it's d1 plus d2. And we want it to be 4,000 miles apart. Alright, so from there you just do substitution. Plug in 4t into there. Plug in 20t into there. There's what we have. Combine our terms. and divide both sides by 60, and you should have about 66.6 hours. All right, I think that's all we have for today. Go ahead and get started on your homework.